support vector machine use kernel method. So what is kernel method? So kernel method is kind of feature extension. So instead of original input vector or input feature vector x, we map using some pi function. And usually the pi function dimension is much bigger than the original dimension of x. So it's basically we increase the input dimension by some mapping pi. And then from this feature expansion, we can use more parameters and which can increase the prediction accuracy. Okay. And in the support vector machine, essentially we use the inner product between the two input and the input and the new input and the previous existing data. So where we basically use the inner product between xi and xj or xi and x. Here x is a new input for predicting the output y corresponding to the input x. And so using the feature expansion, instead of just inner product between original input xi and xj, we do inner product between pi I and pi xi and pi xj, which is kernel value xi and xj. Okay. In the stochastic, in the support vector machine, since all we need is inner product, and the inner product is predefined with kernel function. So to compute the boundary or to compute the output prediction equation, we just need to know the kernel function kernel xi and xj and kernel xi and x. That was support vector machine and kernel. So we can use the kernel method for prediction, like a linear regression. Okay, so the original linear regression was beta 0 plus beta vector plus x. No. The inner product between beta and x. That was our prediction function fx. This was our original prediction function. From feature extension, we can rewrite this one like f0 plus some parameter vector f share the same dimension with your pi function. So this is a new linear regression function using the feature expansion from the pi function. Okay. And actually, without rules of generality, we can change this form like f prime comma sigma prime x. So here pi prime is the concatenation of 1 and pi x function, and f prime is f0 and f vector. Then essentially the previous equation becomes f prime and sigma prime x, f prime and pi prime x. Okay, so from this I will use f and pi x inner product as the linear regression function. Okay, alright. So in the linear regression task, we usually find out the parameter f using the objective function RSS. So maybe we have to optimize yi minus f sigma x pi xi in a product scale. So how can you find the f star, the optimal f star that minimizes RSS function? So usually the kernel trick, the dimension of pi function is very high, even infinity in some cases. Okay, so it is very difficult to define the f star in a unique way, since the pi xi function having the infinite dimension, so there are a lot of solution f star that make the value 0. Okay, right. So maybe we can introduce some cost function like Ricci regression. So you can add lambda times f norm square. Okay, then because of this additional cost function, the solution becomes unique. So that is actually one beauty of the additional cost function. The additional cost function is the main goal or main role of the additional cost function is kind of improving the generalization error. But this also provides side effect. We can more easily optimize function f than before, because this term make your loss function more smooth and having unique unique solution point. Anyway, so using this, how can compute the f star? So f star basically is the point, because this is convex optimization problem, we just need to find the f star that having 0 gradient value. Okay, so then what is f star? So f star is the point we have 0 gradient, and what is the gradient? This point I1 through n. What is gradient? This function pi xi times minus pi xi times yi minus f pi xi plus 2 lambda f equal to 0. Okay, then transpose plus lambda identity matrix f equal to okay, so f star is equal to okay, so you can find out the optimal f star using this form. So this is almost like the same way what we do for Ricci regression. So as we did for Ricci regression, we can find best F star that optimize the objective function RSS plus additional cost function that follow this rule. Okay, so this is optimal F star. So what is the our output y? What is our prediction from F star? So this is equal to F star and pi x in a product. So this is essentially equal to pi x transpose this entire part. Okay, good. So we have the kernel version of Ricci regression, and this is very powerful. Why? So currently we need to expand your input using pi function here, and you have to compute looks like very complicated equation to find the f star, and you have to do some inner product between pi x transpose and f star, and essentially here the dimension of f star and pi x is infinity, so it looks like the computational complexity for here is infinity because the dimension is infinity. But when we carefully check this equation step by step, in the end we have very interesting shape, very nice shape, and the computational complexity for that form is not such complicated, it's not such huge. Okay,